Have you ever had the displeasure of doing a measurement invariance test? It's painful. Not anymore. Check this out. Here's a fairly basic CFA. Let's do a measurement invariance test across early adopters and late adopters, and just run it. It's going to run for a sec. It's doing quite a few complex things, so I'll speed this up a little bit. There we go. Now, first things first, we can see down here, we have measurement invariance. Metric invariance is supported. Here's the evidence. And scalar invariance is not supported. There's the evidence. So let's go look at the invariance tab. Here we have the configural, metric, and scalar invariance tests. For configural, of course, we just want this to have tolerable model fit. And it is tolerable, though not perfect. For metric invariance, we want to see a delta CFI of less than 0.01. Same for scalar invariance. And you can see we observe that here, but we don't observe that here. We also have the RMSEA and the SRMR and the chi-square difference test. The p-value here is for that chi-square difference test, though more recent literature suggests you should rely on delta CFI rather than chi-square difference. And that's why the discrepancy here shows us as passing metric invariance due to the delta CFI, despite the chi-square difference test being significant. Nevertheless, we have not passed scalar invariance, which means we should avoid comparing latent means. We also have the interpretation for metric invariance, which is right here, that group differences can be compared, and usually that's all you need to move on to a structural model in SEM. But if we wanted scalar invariance, we can come down here and see all of the SEPCs, standardized expected parameter change. The higher the value, the larger the difference constraining it is. So right now, we're constraining all paths to be equal across groups. That's what these locks mean. And it looks like efficacy here has several fairly high SEPCs. We've highlighted the top 20% of SEPCs. So if we want to explore partial invariance, partial scalar invariance, we can sort this column by clicking on it. And we can see the biggest SEPC is for efficacy 1. Constraining that across groups is not working very well. So I can unconstrain it by clicking on this lock. And typically you want to unconstrain one at a time. Though if we see that there are a lot for the same factor, there may be justification for unconstraining or freeing multiple from the same factor, as long as you leave at least 2 constrained. If you release so many that a single factor has fewer than 2 constrained, then you have not achieved partial invariance for that factor. So I've released this one. Let's go ahead and run this again. And if it's still pretty far off, we'll release a couple more. Here we go. Just go up here, run again. And we can see scalar invariance is now supported. Hey, look at that. If we go over to the invariance tab, we have achieved scalar invariance just by releasing this one parameter. So we have an option here. We can determine to keep efficacy 1 and claim partial scalar invariance. Or if efficacy 1 is truly redundant, then we may consider omitting that item and running again. So we can see here, here's efficacy 1. It's among 10. That is a lot of indicators for a reflective factor. It's also one of the lower loading indicators. So how about I right-click this to get rid of it, run this one more time, and go to the invariance tab, and we have full metric and scalar invariance without having to result to partial invariance. And we also were able to identify that our lack of scalar invariance was attributable to efficacy, which is now resolved. Pretty easy.